I have never seen a board like this. It's the worst I have ever experienced fixing, and yeah, see for yourself. Enjoy.
This video is kindly sponsored by PCBWay. Thank you, PCBWay.
Welcome back. In today's video I'm going to try to fix a C64 motherboard that was given to me in a job lot, or I bought it, alongside some other boards which I will try to fix in the upcoming weeks, and a lot of Commodore ICs, and there's a video actually, I will put it in the description, a link, where I picked this stuff up and unboxed this. Yeah, in retrospect I think I actually tried to fix, in this video, the worst of the boards. And you will see why. This is kind of an odyssey that took me, I think, 6 or 7 days, on and off. In total I have about 9 hours of video, and that's not even close to the amount of time I put into it trying to fix it. And you will see why. This video is a longer one, and I already cut it down, but yeah, I used this book here, C64 Intern, which is from Data Becker, and this is not the real cover, that's more like it. And it contains the description of all the ICs, of miscellaneous processes in the machine, has complete schematics which I scanned in and put on the screen. And so this was a good resource to trying to fix this. In the end, there was a lot of things that I think went wrong on my part, but there was also a lot wrong with the board from the get-go. So I have never seen a board like this. It's the worst I have ever experienced fixing, and yeah, see for yourself. Enjoy the video, and I will cut in when there's some more to tell. One more thing I actually forgot is to tell you that the board started with a black screen, and when we start into the video there still is just a black screen, nothing on the screen. So there's a black screen with a signal, and that's where we take off. So I did take a closer peek at this board, and I noticed a few things. Since I don't have good schematics for this board, I just pulled up a photo of the board, and I also checked the back side just to see where work was done. You can see these wiggly little worms there. These are board wires. The other side is pretty much untouched. It's just here and something here. But then I checked the top side and I noticed this. There's something and there's something. And in all photos that I have, there's just nothing. And these are just plugged on the top side. So I will remove these. Then I went further over the board and just checked in this area where the rework was done. And there's some black stuff. And if you look closer here, you can see there's this white spot. And this is actually like someone poked into the board. So there's nothing there. It's just plain fiber plastic stuff, whatever the board is made of. So there's no trace, no copper, no nothing. And I will pull all the chips and I will check under the chips, because I assume there's stuff missing there. Yeah, maybe that actually brings this back to life. And there's something under this here, white stuff there. You can see that. Yeah, I will also pull these all and check under these. So if I think it's these two guys here, these here, but you never know. So let me pull all the chips, let me remove these, let me remove all these, and then I will show you how the board looks. Okay, here's all the ICs removed, and you can already see that someone did scrap there with a screwdriver. It wasn't me. And down here is a mark. There's a mark. So I'm not sure if these are still okay. I will measure that. Now we're going to take these off and then we can continue. Okay, these things have been removed. I have to clean this up. Okay, so I did clean between those sockets, and I'm not sure there's kind of a burn mark there. If there's actually a connection between these points, I don't think so. There's some dirt that was under the whatever this is, basic ROM, kernel ROM, character ROM, I don't know. Always forget. These sockets really look shoddy and shitty. I think I want to take them all out, but on the other hand, or the other side, this already looks horrible. So I'm not sure if there will be anything left when I'm done with this. So I'm, for now, opting to leave them in and just try to find the fault. So I will grab my multimeter and connect some thin contact, maybe a lag from a resistor, and put it in here to measure. And I hope that by that I will get a clue what's going on here, because there is something going on here. I'm sure about that. And I'm pretty sure it's not on this side of the board. Now it isn't. It's more on this side. So what I will do is I will put one probe here and connect this. Hopefully this sticks. Yeah, that works, like this. And the other one on this here. And it should beep if we have a path. Let's see. Yeah, it does. Okay. Now we can just go and see what has to be connected and what hasn't to be. So the thing is with these memories, and this is the memory area, that you have some of the pins connected through all the lines here and some you don't have. So the first two pins on this left side are not connected, and the third is. Now I'm going for the fourth. Let's see. It is. It is. Yeah, and I'm going through this like this until I find, hopefully, a pin that isn't connected. Yeah, let me check this and I will be back. Okay, so I found two sockets that are not interconnected here. And I think there should be, because these are. But these here are not. Have to check schematics for that, but I'm pretty sure these should be connected. That would be great if this is the problem. On the other hand, the ones that I thought would be a problem, namely these in here, these pins seem to be, well, except for one, seem to be okay, but maybe this one is also defective. For sure, address line 7, which is down here, second to last, this is because these sockets are 9 pin on one side and not 8, so pin 8 is, or pin is this down here. So these two should be connected to this, and they are not, which can be helped by just a bodge wire. There are bodges everywhere, so it doesn't make much of a difference. Regarding the others, the Q line, which is not interconnected here, and these two pins, this is not even connected, so we can just cross that out. So it's just the D and the Q line, and I assume these two should not be interconnected between these. Let's quickly check if these two here are connected. So these two are not. These two are. So there's a break between this socket here and this socket here. Okay, that I guess can be helped. It's just a little bodge, and we do have quite a few of those, so let's bodge up again. This is a nice board because everything is in sockets, almost everything. So at least the main chips, this should be a good test board if I get it to work again. We will see. We will see. Okay, that's on. So, since I didn't find any other things that could be a problem up till now, let's put the ICs back in and let's see if we get a different result, which would be nice. I think we should go for the Desk Test Max and just plug that in. But we do, of course, need some memory. Let's quickly check if we actually have a connection now between these 2 points here. We do. And we do. Yeah, nice. Everything except for the ROMs is in its socket again. Let's grab a power supply, and this one was buzzing when I last tested it. And it's not buzzing. That's progress. Nice. At this point I have removed those 2 caps, and I have just put in a botch wire to connect the A7 address lines on the RAM sockets. And I tried to start the machine and it came up on Desk Test Max, and I think I just hadn't put in any memory or something, and yeah, I restarted it and now this. Ooh, okay, there we are. Okay. That's progress, since we are all socketed, and I think it can be either the VIC or the PLA. A little bit hanging on the PLA. Let's try a different PLA maybe. Let's see. Do we get a Desk Test Max? We do, but the result is the same. We can try without the CIAs, maybe that makes a difference, but I think without any CIA this is not even working. Now we can swap the CIAs for now. Just see if this makes a difference. And I remember now there were 2 scratches on this here, which I haven't even looked at. So there's a scratch, which I'm not too concerned about, because I think it's not a ground plane, it's just plain nothing. But here are 2 scratches, which don't look too good, which could be cuts. What do we get if we don't put in any CIA? Let's see. We get the same. Just to clarify, at this point Desk Test Max runs, but it shows all the red bars on the left side of the screen, meaning that all the memory addresses are not accessible. So this would mean that all the memory is faulty. There must be a different problem. Let's try the dead test. What does dead test say, if anything? Dead test says no. It's just flickering. Oh, and I just noticed that I put in... oh, frack. I did put one of the memory chips in the wrong way around. I'm an idiot. That is because, and I don't know who did this, because, well, there's a dot on one side and a notch on the other. Why? Why? Yeah, that could pretty much be toast by now. So I will remember that it was this one right here. Let's see what we get now. Now we get nothing. Oh, now we get something. Ooh, baby. Okay, let's assume this thing is toast, because I did put 5 volts where 5 volts shouldn't go. Let's take this out. I think I have a chip tester somewhere. One of those cheapo things. Right here. Can this test? Yeah, this can test 4164. So I have one of these little chip testers here, and I built this from a board I bought off of eBay, this square here. You can get this on PCBWay, the sponsor of today's video, by the way. So here we are on the PCBWay Shared Projects website, and there's actually a DRAM tester here for 4164 and 4864 memories, and this uses an Arduino Pro Mini 328 and an OLED display, and there's actually videos here. I assume this is a guy who made this, and if you want one, you just click on the Add to Cart button. You select what kind of board you want to have and how many. And as I always say, try 10. Most of the time it costs the same as 5. You can see. Submit. Success. And you're in your shopping basket. And now you have to wait for the boards to get checked. You can see one is under review. And you wait until you get an email, and then you just proceed to checkout. And that's how you order on PCBWay. Back to the video. And it's very inexpensive because it just takes I think it's an Arduino Mini, or no, it's an Arduino Nano on here. Easy to program. You just have to get one of these cheapo voltage converters from AliExpress, a few caps, and those sockets. And then you have yourself a multi-chip tester, and the 4164 can be tested with this. You just select here what you want to test, this little screen. We go to 4164 and then you press longer and then it tests. And this is a chip that I just toasted, or thought I toasted, but it passed. Seems to be okay. So that's good. Let's take another one. Can test them all now. So if it's not these, and it's not the PLA, because the PLA surely is good now, then it could be one of these two here, the SN74LS257. So I will test the rest, and if I find something, you will know. Okay, so all of the memory chips tested good, which is nice. Let's try the diagnostics. Let's see what happens. Oh, it's running. Doesn't look good, but it's kind of working. CIA is all over the place. That might be because we don't have any. Did it crash? Okay, so the CPU seems to be running. PLA seems to be okay. So here are two good known good CIAs. Let's plug these in. Okay, let's see what we get. Yeah, same. Let's see what it does now. Oh, yeah, we get a blue screen. That's much better than before. So we are getting close. So we get a correct desk test max. And all is red. And that's what I don't get. Why do we get a desk test max output that is correct and the other outputs are incorrect? I have a feeling the CPU is good. And it's something else. It says here that U1 could be dead if you see a blank screen. So let's switch that out again. What do we get? Nothing. I doubt it's any of the CIAs, to be honest. I did test the board further, and I thought that I found that the 74LS258AN, which is here at U14, was faulty because I didn't get a signal on pin, it's pin 9, address line 7 on the memory. So here's my scope. If I turn this on, you can see, just doing this like this, we have action here. And we have action here, and I am on pin 11 now. This is pin 10. This is pin 9, and pin 9, as you can see, oh, now we have something. No, we don't. It's just a flur of this here. Yeah, so the address lines are working, but still we don't have anything on address line 7. So let's investigate further. I have a book, and this book is called C64 or 64 in turn, the big Commodore book. And not only does it have the full schematics, which I already put a few things on, but also what it has is a hardware part. So you have all the descriptions for various things like in the original C64 Commodore manual. You have this here, schematics, and it tells you in detail what happens when. So if you do this, this cap gets loaded, and then this cap after 30 milliseconds gets unloaded and all that stuff. That's pretty interesting. I'm thinking about turning this into a video just to show how the C64 actually works when you switch it on. So not just what's happening here, there's some memory and you start at an address, but on a hardware level. So what happens in these components? Where does the voltage go, and what does this do, and how does this whole life cycle work? Because in the end it's kind of a loop, and I want to show that because I want to learn that. So best way to learn is to show. Yeah, so if we take a look at the schematics, and I will, problem is I don't have good schematics here, I just have these. Maybe I scan these quickly. Now let me quickly scan these and then we can put them on the screen. Because so here's my scan. Now, it looks pretty good. Yeah, that looks really good. I can actually read the numbers and all. That's good. So the thing I changed out is U14, and you can see that address line 7 goes from pin 32 on the VIC into pin 11 on U14. And then it should come out, and it didn't. So that's fixed. There's something coming out now. We can take a look at this in a second. This is the old LS thing I had. Let's test that quickly. And let's see if this is really broken. So I'm using my Mini Pro here. You go to Logic IC test at device, enter your thing, 74258. There it is, and then you press test. Oh, and you can see it was broken. That's that. Let's put in the one that is in the machine right now. Let's check if this is actually good. So that was another fault. So we have broken traces down here. We have the fault on the LS74 LS258. Let's test this one. Okay. Oh, that failed too. No, it doesn't. Wait. Let's put it in again. No, now it works. Seemingly. So how did I spot this? When I looked at this and I saw that there's the VIC, and on pin 32 there should be in the address line 7 going in here. Or is it coming out? I think it's coming out of here. However, nothing was coming in here or coming out here, depending on which way you look. So you have this A3 and B3, and I think this should convert to what is here Y3. So these are, if I'm not completely mistaken, connected. And if you look at A2 and B2 and Y2, you can clearly see a signal, and there's no signal on Y3 here. So that's why I changed this out. And we have that. That's good. So whatever happened to this board, I assume it did get too much power and it toasted all the stuff along the 5-volt rail. And I do assume that one of these LS257 is damaged too, because if we go and take a look at this here, these are not labeled, but this up here is U13 up here, and it's U25 down here. So if you take a look, A7 comes in here on pin 10. Let's check that, because all the data lines, all the address lines should be on here. So let's test pin 10. So nothing's coming in here. And let's check where this is coming from. So let's check, where does this exit? Here does it. It comes from CIA U2 and mostly from the CPU. So address line 7 is pin 14 on the CPU. Not much happening here. Not sure what's up here. Did the CPU just die? I mean, we had the blue screen already, now we have a black screen again. This machine is killing me, man. So something went horribly wrong here. And I'm not sure what it is. Okay, I guess we start at the beginning. Nice. What we should check is, do we have a clock? And does the machine come out of reset? So let's check for out of reset first, which is pin 40. We just switch it on. And it's active low, so it should be low and then high. Low, high. It's a very noisy low. Do we have activity somewhere? Let's check on the address lines. That's ground, and it's always high. So it looks like the machine is in halt. No, there's read-write activity, and we have a clock. And we have a clock in. Didn't do anything, but now it fails at the VIC chip. Great, let's switch out the VIC chip again. Maybe it's faulty, I don't know. Let's see what happens now. Do we get... now we are back where we were. I don't get it. Can anybody tell me what happened? Except for that this VIC chip seems to be faulty and I didn't know that. So that gets a question mark now. Let's check if we get activity on the address pin. So we still have nothing on address line 7. And let's check again where address line 7 comes into play. So it leaves from here. So the MPU is the originator of the address line. And address line 7 is at pin 14. So let's check that again. That's where we left off. Do we have anything? Still looks messy. 4 address lines are handled by the CIA. And the CIAs are good. I already know that. So that goes out here and it enters here. This goes into the basic ROM, kernel ROM, character ROM. Okay, this also doesn't go just here, but it also goes up here. And that's where it's getting interesting. So after reading more and more on this, I'm pretty convinced that all this works, and it has to be these two multiplexer 74LS257, which are also dead, because this one was dead, and it was really dead, even fried, I would say. I assume all the memory chips were fried. That's because they are socketed. And yeah, let me remove these two LS chips. Let's test them and let's replace them. And I'm pretty sure that if we do this, the machine will work. But you never know. Okay, so the first one is out. The first of the 257Ns. Let's test this in the Mini Pro. Okay, let's see what we have. And it's broken. I knew it. It was the only thing that could be faulty here. Okay, and I'm pretty sure that the second one is dead too, so let's extract this one. I have a stupid feeling that all of these LS chips might be compromised. But yeah, let's first get the other one out and test, and then we can go from there. Okay, second one is out too. What do we have? Yeah, it's intermittent, which is... now it works. Now it fails. Now it fails all the time. Okay. So it made bad contact, was intermittent okay, and now that I actually put it in correctly, it always fails. Okay, so that's that. That explains why all the memory addressing didn't work, and desk test max told us to go and F ourselves. Okay, let me put in some sockets, new chips, and sockets are in here and here. Looking good. I have 2 tested 257. Could be that this was already it, but I have my doubts. I think there's more to do. We will see in a second. It's the same. It's still the same. Let's pull the desk test. Yeah, we still get this blue screen. Man. I mean, it could be that all of these ROMs are toasted, maybe except for the character ROM, or the basic ROM took the hit. Let's take out the basic ROM. I don't trust this basic ROM a bit. I have no way to test it. I could put it in another C64, of course. That would be too easy. Oh, still the same. What if we take them all? Let's see what happens now. Do we get anything? It's the same. Yeah, so we are pretty much down to the remaining LS chips here. Yeah, so all the memory management happens down here. And all I can do now, assuming that all the connections are there, and I didn't see any ripped traces or anything, all I can do is change out all of these chips here, because chances are they are all faulty. Let's check what's next on the line there. So next in line would be the 74373. Yeah, and in parallel the U14, which I already have changed out, which was faulty. So chances are this one is faulty too. Next order of business for me would be to change out the 74LS373 and then maybe continue to the U16, which is that guy down here, and maybe even U28. I can't see U28 here. Let me switch out the LS373. And the next one's out. Let's check. We have a 373. Let's see what we got. Yeah. Faulty. Totally faulty. Oh man, this is a complete mess. Okay, let's put in a socket, let's test, and probably let's remove them all in the end. And another socket is in. And I have a board here which should have a 373, which is tested. This is, by the way, a board I have to fix too. So yeah, all I take off here I have to put on eventually. Let's see what we got. Yeah, it's still all the same. Ah, that's crazy. So next in line would be these 4066 BC and the color RAM. So I took a long shot and I thought, if these are toast and these are toast, then maybe these resistor packs in between are also toast. So I went to a donor board and desoldered some of these, of course breaking a leg or two, just to learn how to measure them. And there are two different types of these resistor packs. And pin 1 is always where the dot is. And you have resistor packs which you can measure just by pin 1 and then each pin individually. Or like these here, which are individual resistors. So these things are nothing more than just resistors in a pack. And in this type of pack, it's even so that every 2 legs is 1 resistor. So you just measure them like a normal resistor, and this should have 33K. And if we go in here and we measure, you can see it's 31 and the second, and the third, and the fourth. So there are 4 resistors in here, 33K each, and 2 of these make 8 resistors, and these are connected to the individual pins of the memory bus here. So these are okay. I also measured these. You can measure these in circuit, so they measure okay. So they are not shorted or anything. They are totally okay. And so the next thing to take care of, which can take a hit if you have all the memory and you have the resistor packs and you have these 2 LS chips and you have this LS chip, the 373, the next thing that takes a hit is the color memory. So I'm going to remove the color memory and put in one from a donor. Hopefully that works. I have no way of testing these. So yeah, this is a 2114N. Okay, I did put a socket in here and found another color RAM on one of the other boards that I have. Put it in. Let's see what it does. Yeah, it's the same. I mean, the colors weren't bad, so, and it all looked good color-wise, so it would have been a long shot that the color RAM was a problem. Dead test, yeah, that's pretty much the same as before. So we do see just stuff in here, and we see that the machine is running, so it's running, but it's not displaying the right stuff. So there's clearly some memory issues here, and it seems that the VIC chip is trying to access the memory and it can't. So there's something in between there. So what do we have? So I just replaced the color RAM, which is, color RAM is here. So RAM is here. I replaced this one. I replaced this one. You can see there's just one thing between the RAM and the VIC, and that is this 406060. And that's going to the color RAM, and that has the data lines. Is this data lines? I think it's the data lines coming from here. So it could be that it's just always getting some stupid data like 0 or something. And that would normally mean that that there's a break between some data lines or address lines, but it looks more like data lines actually. So data lines could be a problem, and that would be the 4066 at U16, which is this right here. So let me replace this one because it's in the way. And we have U28, which I can't even see on the schematics here. Let's do in a kind of a final attempt, which of course is not the final attempt because I'm going to fix this board, whatever cost. Let's replace U16. Okay, socket is in, and you can actually test these 406060 in the Mini Pro. I just got a replacement here. Let's put it in. Let's grab the Mini Pro for fun and let's see what it says. I put in 4066, yeah, there it is. And test. I'll be damned, it's faulty. Another one. So the question is the last one also dead? So that one is dead. So we have quite the carnage here. Man, man, man. Okay, so let's plug the machine in and let's see what we get. Do we get a different result? At least. Oh. Oh. What the? I have never seen anything like this. That is interesting. Let's try again. So it seems we don't have any more memory faults or RAM faults. Ooh. Uh-huh. Wow. So now we have intermittent faults, which is always great. I think there's something shorted in here. And I am afraid I have to take out the second 4066 too. There's 1, 2, 3 more LS chips. 74, 06, 08 and 139. So let me take out the D4066, the second one, and let's see what it does. Second one of the 4066 is in. Let's test. It's also dead. They're all dead. I would say it's almost impossible, but it seemingly isn't. So, okay, do we get a different result this time? Oh man, that is just not funny anymore. It could be that I actually produced a bridge here somewhere. Let me quickly check. There's something that looks like it is bridged. I'm not sure if it actually is. So let me quickly grab some wick and try to remove it. And let's see if that's actually a bridge. That shouldn't be there. No, that bridge is on purpose. So we are still not good. Did I solder all the pins? Let's check. Because you could easily lose sight here. There's one missing. What's that? I might have desoldered this while I removed those LS chips. So maybe that makes a difference. I'm not sure. I would say we will see. Okay, we are back to where we were. I guess I'm in for a treat. And I will now remove. What will I remove now? I'm not sure. So we have a 373. We have two 4066. We have one 257. We have another 257. We have another 25. No, there's a 258. So we have all these which were dead. So now we have officially removed all chips that could have been bad except for these four. 7408, 74139, 7406 and this 556, which I think is just for the cartridge port. Or the tape. No, I think it's for the tape. So, which one next? You may ask. Let's check the schematics. So, what's next in line? Where's the 7406? Yes, the 08, which comes in here and goes to U17. U17 is our friend PLA. Yeah, I think I'm going for the 08 next. That seems to be responsible for the ready signal here, and this signal here, which then... Ooh, yeah, I think the 08 is the next. That's this guy here. So, same procedure. The 08 is out. Let's check it. 7408. And it failed. Man, that's just crazy. Another one. Bit the dust. Okay, now I need an 08. So, the 08 is in. Fresh and shiny. And here goes nothing. You must be fucking kidding me. Every single chip I pull from here is dead. And the machine still does not boot. Let's remove the 39. The 139, I'm not sure. Just let's see what happens. We have a 74 LS139. Ooh, wait. That one's good? Oh, it's not good. It's intermittent. Let me clean this up because I just put it in here. It's pretty dirty. Don't want this to interfere with anything here. Let's try this again. Yeah, now it's failing. It's still intermittent. I don't get it. Is it dead or is it not? No, it's okay. Let's put in a new one. Let's see what happens. No. No. Two left. Two left. This is just crazy. And I just noticed, maybe this is a problem. I mean, all these chips were dead or borderline dead. So, but what I just noticed is there are some scuff marks on these traces, and I didn't do that. Not sure if these are actually good or if these are cut. They don't look cut. Thing is, I don't know where these go. And I'm not willing to remove even more sockets. I mean, they don't look horrible. I think I will just scratch a bit and see what we get. Let's try this one. Oh, that's good. Nope. Then here's another one. Two cuts. Oh wait, here's another one. No cut. No cut. No cut. Okay, so no cuts there. That's good. Let's remove the 7406 on the board, which will be the second to last non-socketed chip so far. And if I remove these two, all the chips on this board will be socketed. Okay, ladies, almost there. Let's check the 06. It's dead. Oh man, I am not surprised. I'm really not surprised. Something did grill this machine bad. Every single chip in this machine. So chances are that the final one, which is not socketed, this 556 PC, is also dead. And I will have to change it. But first let's put in a 06 and let's see what happens. Let's see what we get. I'm pretty sure we don't get a running machine, but you never know. You never know. This is impossible. It's still faulty. So there's only one left. And if this doesn't work, I just don't know what to do. I'm out of ideas here, guys. Could of course be that every single one of these little caps here is toast, but I hope it's not that. I mean, all the chips were dead, so didn't do any work that wasn't necessary. It's just that, well, maybe this is the final straw. Let's see. Let's remove this. We've come so far. Let's walk the rest of the way. Almost there. Okay, new 556 is in. Let's see. Oh man, what now? What freaking now? I mean, the only active components here are these transistors. I mean, let's quickly measure here.
This transistor is not grounded. Another candidate for desoldering. I guess we have. What is this? This is a C1815. Would probably tell us why we have low voltages, now that I think about it. Let's see what we have. Please. Still not! You are fucking kidding me! That machine. But now I have a fully socketed board of a C64 that doesn't even work. Let's try the dead test again. Let's see what that does. So it would seem that there's a break on the board somewhere, because that's the only thing that can be now. Since I've replaced every single... yeah, it's the same. Every single freaking chip on this board. So I did take another look at the board, and I will show you in a minute what I found. I also went and did test all the LS chips that were in here, and I found that actually 3 of them did die. Either they were dead or they were killed by the board. So I put in new ones. Still no luck. Then I, in a final attempt of desperation, I did remove those 4 sockets. These are the memory or RAM sockets. You can just flip them up with a screwdriver. So you take a screwdriver and then you can go under here and push up, and this lifts the plastic, and under the plastic is more plastic. These things here and these little legs. And if you lift this up, all the legs are still in there, so you can desolder them one by one, which I did. And then I took a good look at what I found, and let me show you what I found. So here we are. Yeah, what you see here is rough. So let's do this bit by bit. I did check all the traces. These are all okay here. This side is completely okay. Still have to pull the solder out of these holes here before I put new sockets in. This right here looks good. Go down here, we have a bit of stuff. And then we come to this spot, and this is just, there's nothing. That's pure board. So this trace here, which has to go over here and has to go over here, is just missing. And that's okay, because there was this wriggly wormly wire on the backside which did go over here. So that was taken care of. We have another one of these up here, and you can see there's a trace that goes from here to here to here, and it's broken on right here. There's just a burn mark or something, and here. So there was a wire from here to here to here, which was also taken care of. So that's all there was that was fixed, and I did not destroy anything of this. So this is all as it was. There's just some stuff here which we don't care about. Look at this. This is short. So this is just solder, but this should be isolated. And there's solder, and it connects, I think, three points here. This one, this one, this one, and of course this one. Not sure if this bridge should be here. I don't think it should. Then we have this here, which is, well, hanging in there, but very, very barely. So this should be up here, and it's down here. So I'm not sure if this can be saved, so maybe we have to put something new in here. No connection here, which is good. We have a connection here, which shouldn't be here, which connects this trace with this trace, and this trace with this trace, which should be here. So there are shorts all along. Yeah, no wonder that didn't work. So I will fix that. And I had to wait because all my solder wick, my good solder wick which worked, was gone. I just had this super thin, flimsy stuff which I will just throw away because it's really shitty and doesn't do anything. But fresh came in, so I'm good to go now. And yeah, I will fix this. So this is a total mess, as you could see. Glad I pulled the sockets because they were the only thing that could actually be faulty. And how did I get there? I did tap on these chips, and when I tapped here, something changed. And I thought, that can't be it. I soldered this socket and it's in there and the chip is in there, so it must have been one of these sockets or one of these sockets here. So I will desolder all these holes, I will fix all these traces, and then I will put in new sockets, and then we will test, and then if that doesn't change anything, I will go and put new sockets here. That's my plan. So I did put in the new memory sockets, at least these 4 here, these are the old ones, and I got a black screen. And I was very confused because, well, we saw more before. Then I checked the backside and I noticed that this little fella here on the side had a connection to the ground plane. And yeah, then I did correct that, and when I measured the clock on the board, there was nothing, nothing at all, just black screen, nothing. And then I looked to the side and I noticed that the fuse was blown, so I did change the fuse. I'm still getting kind of a black screen if I put in the Desk Test Max. If I do not put in the Desk Test Max, I get something different. And I thought, how can that be? Because now it should actually work. I did measure all the lines from here to the VIC and to the PLA. These are the 2 ways these lines go, those data lines and read-write lines, input and output. And I found 3 of the LS chips dead again. And these are only the 3 I measured. So now I'm measuring again, and I find that the LS06 is dead here, and that the 258 is dead here, and I assume all of the LS chips are dead again. So I have to measure these again. And since they are in sockets now, we can just do that. And yeah, let me switch over to the desktop, and then we can go and see what we have. So this is the 258, which was in here. If I go to test, yeah, there's always tests bad, which is the one that sits here. So I will just put it there so that I don't have to guesswork which chip goes where. I hope I didn't blow more. This is the 08, so I already know that the 06 over here is dead. To find another one of these. Oh, that one's good. Okay, nice. At least one has survived. We have the 139. And it's dead. So I will just put the dead chips on top so that I can easily see them. Let's check these 4066. That's good, nice. At least something still works. The other one. Yeah, that's really shitty if I actually blew these chips. Yeah, that one's dead. And we have, this is a color RAM. Just leave this in here because I don't have a spare. At least none available right now, which I can just plug in here. I have to desolder one. And I'm really done desoldering for now, because desoldering these sockets was just hell. And cleaning all the holes and making them work and putting in the botch wires on the bottom and all that stuff. It's really took me hours. 373. Nope, dead. How it works. Now it's that again. Not sure if... What's going on here? Really not sure. Oh, now it works. Now it's dead again. Now it works. Now it's dead again. Now it works. I don't know. Man. Okay, let's test the 257. Nope, that. Let's put it in here. Now it works. Could it be that this thing here is gone a bit? Now it fails again. Now it works again. So if I put it in here like this, it works. And if I put it in like this, it doesn't. So what's right now? Does it work or doesn't it work? I don't know. So I have to test all of these again, because now I know that probably they are okay or not. No, that's good. So in the correct position, they seem to be okay. So let's test this again, 373. If I put it in like this, it works. This is not good. Not good at all. Oops. Test this one again. This is the 139. Put it in like this. Test. Okay. Oh man. Now I can't even trust my test equipment, which is really shitty. 258. Okay, so the 258 fails all the time, at least something. 4066 did fail. Yeah, still fails. Okay, so these two took the hit here. And we have the 06, which tested bad. Let's check that. 406, and we have to select the OC Dingenskirchen. Yeah, that's dead too. Okay, so we have 3 dead, and okay, let's change these and let's see if the machine works. Then I'm really done with this. I spent days trying to fix this, so okay, good for another test. Let's see what happens. Not holding my breath here. There goes nothing. And nothing is what we get. We get something different, but still nothing. Let's see if it's at least stable. Stable, nothing. Now it's just a black screen. I truly don't get it. So the only thing getting really hot is the VIC chip. Let's maybe remove all the chips again if we don't need, just for good measure. Still the black screen. Let's check voltages again. 5, 10, 12, 19, oh shit. That did short something. I know it. Okay. And still a black screen. Nice. Okay, let's see if we have a clock. Do we have a clock? Which should be here. We do. Do we have... Are we out of reset? Reset is active low. So yes, we are out of reset. Do we have activity somewhere? Let's check pin 20, which is address line 13. So there's nothing on 13. but there is something. Okay, these are just high. So something is pulling these address lines high. I'm not sure what it is. That's new. Whoa, that VIC chip is really hot. Could it be that the VIC chip died? Let's quickly check where these address lines go. A0 to A13 go right here. And they also go to the VIC chip. And they also go to the color RAM. Just down here. Could it be that the color RAM is dead? I mean, it didn't look like it before, but maybe it is. Let's just switch it out. I have another one. I just found one. Nope. Just the same. So let's put in the old color RAM. Let's remove the CIAs because we don't need them. Let's try again. Nope, black screen. Do we have a short somewhere? Let's check for shorts. Oops. Doesn't seem to be a short somewhere. So my final attempt will be to replace the VIC chip. Same black screen. A real final attempt. Replace the PLA. It's all the same. The only thing I can think of, it's getting warm again, is that one of these LS chips died again. So let's check them again. Let's try the 257 first, because this is actually related to the memory. That tests good. I mean, we have an AN and a BN here. Not sure if that makes a huge difference. Yeah, that says that. In all positions, 257BN is dead. So the only 257 I have is this very beat up chip here, which I have to clean before I can use it, but it tests okay. Okay, good for another test. Let's check. Nope, same black screen. And I'm 99.9% sure that this thing just died. Let's check. Let's see. Fuck! I hate to be right. What the... So something is killing 257 chips in my board. At least I know that now. And that one too. So whatever is killing my chips here is just killing the 257s, which are right next to the memory. Okay, I didn't give up, and I found another spot that was bridged, and it is right here. So this blob and this blob was just one blob, and it might look pretty big in this under the microscope, but it's pretty tiny. So yeah, that might have killed my chips here, because this is, let's check the other side. Yeah, that's right where the 257 lives, right here, U13. I have no idea if there's something similar down here, so I might check if I find spots like these on the underside. So let's see, what do we have? We have, so this right here is one of the memory chips, and these look all good. Hoping that this right here doesn't make contact down here to the trace. That would be bad. That's just some dirt. Going over here. It looks all pretty horrible. Yeah, that's, I think this is okay. This is ground. Oh, is it 5 volts? I'm not sure yet. This is okay. This seems to be okay because there's this little curve here which indicates that this is like this. There's no connection here, I hope. No. That looks good. This up here, this one is interesting. So there could be a connection here, but I don't think it is. No, it's just dirt. Down here, looks good. That's my work. Just hope that doesn't make contact here. Let me bend this over here. I think we're good. So I don't see any other bridges here. And I know, looks like hell. And I will clean it. Here's one of these spots. I can't be sure that it doesn't make contact. There's even something missing, and here's bare contact without anything. So I will put something under there, I think. Some kept on tape or something. Just to make sure that it doesn't short. I will put some conformal coating on there. That should be good then. So let's see what happens if we start the machine now without the 74 LS257s, if it does anything at all. No, it's pretty much the same. Does this prove anything? I don't know. To be honest, if it proves anything. I'm so tired. I do have my bag of dead chips here. Let's quickly take a look at these. These are only chips that were in this machine here and died in this machine, so maybe something is still working. I will retest all these chips because, well, I don't know if they actually work. 258, 257. So let's do the testy again. Yay. Still on 257, so let's test. Let's do that. Let's test this one. This is jumping all over the place, so this might actually be okay. Nope. So these two are definitely dead. Let's check the 373. Nope, that's dead too. 139. Dead. Yeah, and I assume all the others are dead too. 4066. Could still be good. Dead. And the other one. Nope, dead. Okay, so these are all actually dead. Yeah, that was quite the LS chip grave. And now I need two 257s to actually check if the board works now. And I have to desolder these. Okay, still not giving up. I have two 257AN rescued from another board. And rescue is a big word here because, well, it was more like a slaughter of that board. Okay, let's connect. Let's see what happens. Not holding my breath here. I can't believe it. I think I did it. I think I did it. Oh man. Finally. Man, what a struggle. Okay, let's put in the other chips. Let's try the dead test. Let's be bold here. Yeah, it's counting. Oh man. What a struggle that was. What a freaking struggle that was. Color on bed. Of course. Of course. Why? Why is color RAM bad now? U21. Okay, I have color RAM. Oh, that's getting toasty. Let's put in another one. Not done yet, it seems. Let's try that one. Just hope I'm not going to toast color RAMs now. Come on, man. Give me a break, please. Color RAM bad. So it could be the color RAM, or let's quickly check where the color RAM goes. Before it goes to the color RAM, it goes through all of these three here. The basic, kernel, and character ROM. So it could totally be one of these. Let's see what we get if we don't put anything in. Okay. That's not bad color RAM. That's just a working C64. I have so many fumes from my soldering things here in me now. I can't barely breathe. And I have my fume extractor here, still running. It works. I will be damned, it works. So let's put on the full test harness and let's see what it does. Could it be that the dead test is not equipped for the 250425 to test? I don't know. Let's do the full shebang. Okay. Control port bad, interrupt bad. That's not good. 6581, sure, there's none in here. U12, U21, U22, U23, U24. That's memory, for God's sake. How can memory be bad here? I thought we were over that. And the CIAs are not doing much. CIA at U2, yeah, that's the short-legged guy here. So let's maybe pull that one again and put another one in. Let's see. Oh, now we are running wild here. But the RAM test passes. But everything else fails. Oh shoot, I did put it. I'm such an idiot. I didn't put in a CIA, I put in a CPU. Oh no, that might be toast now. So here's another 6526 CIA to test. This machine is positively killing me. Okay, now both CIAs are dead. You must be freaking kidding me. Okay, so now it's just the interrupts. And U2 is bad. Okay, let's switch out U2, I guess. Again, I mean, it has a check mark, but it doesn't mean much with the CIA, because it heavily depends on if it's put into U1 or U2. And if you really want to thoroughly test a CIA, you have to put it in both places and test it. Maybe it were just the crusty ports or the crusty sockets, and that helped. But we didn't get any memory errors, we didn't get anything, so that could actually be a good thing. Ah, now control port is bad. And interrupt is bad. And 4066 at U28 is bad. It would be this guy. Haha. And the VIC is really toasty. Let's switch out this 4066. Maybe that is our problem, which I don't think, but you never know. Let's see. Oh. So the 4066 actually was bad. We still have a bad CIA at U2, and we don't get any interrupts. So it's again the next day. I don't know, 6 days in now, which seems a lot, and it is, but it didn't work all day, so yeah. I did test this machine, and I could play games just fine. Demos, everything. But still, this interrupt thing, well, it's not sitting well with me. So I read up on this, and there must be a problem between these two CIAs. And yeah, that's pretty much how the diagnostic cartridge determines this. It does an IRQ or an interrupt request on one CIA, and there should be an interrupt on the second one, and vice versa. So let's take it out of the case again. I already had it here in this nice-ish case. And let's see if we can spot something. I don't think it's the CIA, to be honest, because, well, there were 10 or so CIAs which I put in there, and every single one failed. So that's very unusual. So I would say there's something on the board which is not going well. Some cut trace or something. And since I didn't actually check this section too well, I did inspect a bit and scrapped away some stuff and measured a few of these things where a cut was, but you never know. So let's take it out of the case and let's check it out again. So here we are under the microscope. So the CIA area is up here. I think I checked everything, but you never know. Yeah, this right here should be a CIA, and this right here should be a CIA. Everything looks good. Okay, let's turn the board around. Here are our CIAs. Let's take them out of the socket again. And we do have a bit of scratching in there. Okay, so let's first go for these, because these don't look good. And it is. This should be going to here. And it is. And this should be going to here. Or here. And it is. There's another one which goes from here to here, which it does. So I can't see any other problems here. Sockets look totally fine. I mean, these are single sockets, so there's only one side that is conductive, I think. Maybe it just needs a bit more WD-40. Let's try this again. Maybe it works, maybe it doesn't. At least we did check. Okay, good to go. So what is strange is that we don't get any timer updates yet. So interrupt that. That is really strange, because there should be timer updates and we don't get them down here where AM PM sits. So it always shows U2 as bad. Okay, since I have no idea if the CAAs are the problem or not, I brought out another machine. This is the one with the clicky keyboard and which I painted with my son. So let's see if this still works, then open it up, put in the CAAs, see what happens. Easiest way. Yep, works. Okay, let's open it up. So this is actually, oh, it's actually the same board. Just noticed. Ah, if I had known that, I could have measured all the values and maybe saved myself a lot of time. But well, it is what it is. So yeah, it's actually 25 board, and we have at least all the main ICs socketed, nothing down here. Okay, so let's pull. And I think these are actually the original ICs because these CAAs look completely fine. Let's go and do a run with the diagnostics just to get a baseline. Maybe the CAAs actually did update. So there's something wrong with the other one. Okay, so this might be because I have a non-standard SID inside here, the SID Kick Pico. Okay, so we have a baseline. This actually does work and it doesn't say interrupt. So there are diagnostic programs that show a fault, at least the internet says so, on CAAs that are older than 86. No, younger than 86. Everything that's produced after 86 can produce a problem. So this is from 84. This is from 84. So it shouldn't be a problem. Yeah, just jumped. So this CAA is completely okay. Question is, what is the freaking problem here? It's not the CAA, which is good news. So here's our CAAs, and we have an IRQ coming in on pin 21, which is an interrupt request. So according to the diagnostics manual, by the way, this is a very good troubleshooting guide. You can get, actually, I think you can fix a machine with this because it's a step-by-step, at least down here, troubleshooting guide, and it tells you what signals to measure and what should be there. And it also tells you what happens in all these tests. So we have beginning with a 0-page test, stack page, screen RAM, and we also have down here somewhere the interrupt test. So the interrupt test checks the internal timers of the 6526 CAAs U1 and U2 using the IRQ and NMI vectors. So we have IRQ on this pin here, which is 21, and NMI is, here's NMI on pin 21 of U2. So these are paired, and U2 has NMI and U1 has IRQ, it seems. And NMI is active low and IRQ is also active low. So we have two active lows. Where does the NMI come from? It's connected to, okay, we have another NMI on the CPU pin 4, and there must be an IRQ on the CPU too. So where is it? So this NMI is connected to the CAA2 NMI. So these two pins must be connected somehow. And they are also connected to the expansion port. Now let's check IRQ. IRQ comes out of here. and it comes in here. So we have IRQ here, which goes to the expansion port and then goes over to the IRQ pin 20 on the VIC. Okay, there are a few things we can try on this machine. And the first one would be there should be a connection between pin 21 on U2 and pin 4 on the CPU. And there is. Okay, so we have an NMI connection. Let's check that here. So we should have a connection between this and this. And we do. So we have the NMI connection, which is good. We should also have a connection between pin 21 on U1, which is here, and pin 20 on the VIC. We don't here. Let's check if we have it here. We don't. Why? Pin 21 here on U1 is here. Or is this 31? No, 31 is up here. It's 21. And that is connected to, is it pin 3 on the CPU? Yes, it is. So it should be connected here too. Pin 3 on the CPU. Yes, it is. Do we have a connection between pin 3 here and pin 20 on the VIC? That doesn't check out. Yeah, I think it's pin 8. Wait. So it should be between pin 3 here and pin 8. Yeah. Okay, we have that. And we have that. That's there. So does pin 8 go anywhere else? We have it here. No, it's just a straight line. It comes in from here. So that's all the IRQ we have. We don't have any NMIs, so these should all be on this page. I mean, the connections all seem to be there. I just don't get it. Okay, let's continue reading here. So, an interrupt is not sensed on the IRQ of the 6526 CIA U1 or the NMI of the 6526 CIA U2. The interrupt is bad. If both interrupts are sensed, the interrupt test continues. The internal alarms of the 6526 U1 and U2 are tested by adding 2 seconds to the clock and waiting for the alarm interrupt to go off. If the alarm interrupt is not sensed, the interrupt is bad. So it could also be that, as I understand it, these two CIAs generate an alarm interrupt, and if that is not generated, then it's bad. But we know from this board, the working board, that these two CIAs do in fact generate the alarm. But we don't see any timer change on the diagnostic screen. The data line interrupt is tested by outputting on the CIA U1 and waiting for an interrupt to occur on the CIA U2. Data is then output on this 6562 CIA U2 and a check is done for an interrupt to occur on U1. If the interrupt occurs, the interrupt is okay, else it's bad. If the interrupt displays bad, refer to the failure chart in section 5.14. If this does not correct the problem, troubleshooting of the associated circuitry is necessary. Yeah, so that is this timer thing here. The timer tests check the internal clocks of these U2 and U1, the CIAs, by setting up the timer pointers and 1602 addresses to be utilized. The timers are set to run at 60 Hz derived from the TOD inputs on pin 19. So it would be 50 Hz. Oh, pin 19 on the CIAs. Maybe that is the thing, because we don't see the timer change. Ah, here it is. Yeah, 50 Hz TDD. And that goes to our good old friend 74 LS08. And there also is U27. So this gets a 9 volts on R5. Ah, R5's up here. Okay, so we could measure the 9 volts here, and it should have 560 ohms. Let's check. See if we can check this in circuit. Yeah, 546 seems to be okay-ish. And that goes to R100 then, and to C200. C200 is right next here. So we should check R5 and see if it gets 9 volts. So let's put in some voltage. Let's see if we get 9 volts. We get 4.4, which is a bit low. It says 9 volts AC here, right? Ah, okay, it's AC. Wait. Just noticed something. So this is supposed to connect pin 14 of U2 to pin 3 on this U27. Let's check. Pin 19. And it's both pin 19s, so should be this guy. And we have our friend here, and that is pin 3. It's not. Huh. It's not connected. Could it be that I actually found the fault? No, there's no connection. Let's check if there's a connection on the other machine. So pin 19 here. It's hard to see now. And pin 3 on U27. No, there's no connection. But there's a connection to pin 9. Yeah, pin 14 and pin 19 and pin 9 are connected. So that might be that I did read the schematics wrong, and that it's a 9 and not a 3. So it's just plain wrong there. That is connected, and that is connected. Okay, so yeah, we didn't find anything. But we have that low voltage. So this connection is there, but it's pin 9 and not pin 3. And that should connect also to R37, which is up here. So pin 19 should also go here. It does, but it does on this side. That should be 2.6 k ohm, yeah, 2.7. That's correct. And I also found R100, which is supposed to be 1k, and it's 790. Could be that it was changed on this schematic here. Not sure. Let's measure the other one. So R100 is, no, it's a k ohm here, and it's 2.7 here, so that R100 is definitely too low. So that should be higher, and R5 is 560 here, and it's pretty much spot on. Only thing is, we don't have 9 volts on the thing. Let's quickly measure with a bit more reliable equipment. So let's see, on pin 10 and 11 we have 9 volts AC, and we should have 9 volts AC coming in here, but it's the same 9 volts AC, so there is 9 volts AC, because it goes from here down here in the 560 ohms, and we should be able to measure this on R5 if we put one probe here. One probe here, right? Yeah, it's 9 volts, spot on. Okay, so we have that. So the only thing I can find is that R1 is just a bit too low. I'm not sure if that is really a problem, but I will, of course, go and change it out. Okay, fresh R100 is in. Not sure if it really makes a difference, but we will see. Okay, machine still works, which is good. Let's put in the diagnostic, and let's try it without the harness, see what it does. Should still show some signs of CIAing. I'll be damned. It works. Wow. Could it be that it really just was this stupid resistor? No. But we have a clock now, which is progress. So let's connect the whole harness. Maybe it's something different now. So again, we made a bit of progress. We have a clock, which we didn't have before, which is nice. So this will be added to the bag of shame here, which I will put into the case of the machine just to show how much stuff was actually broken in this, which is crazy. Yeah, clock still works. Yes! It was this freaking resistor R100. Oh god. I did it. I finally did it. Man. It was just a weak resistor. That was hardcore. I'm speechless. This thing almost broke me. So having it working again is just fantastic. So I will do some cleanup, put some heat sinks on these because they really get toasty here, especially the CPU and the VIC chip. Mark everything as good. So let's quickly recap what happened here. Let me switch over to the desk again. So I had this board, came in a pile of other boards, which is, I guess a year or so ago I made a video about a pickup of a lot of Commodore stuff like ICs and boards and all that. And this was one of the boards which came with this. And I didn't work on this, hadn't worked on this before. This came like I got it here and showed it to you. And it seems that it had gotten some overvoltage, and that took out all of these ICs except for 3. So 3 ICs of this are mine. I did that. And the fuse. All the others were just dead, and they were not socketed. They were soldered to the board. I had to remove all these. I had to put in new sockets to actually socket these. These little caps were soldered to the board up here, and I think this could potentially be the overvoltage, I don't know. We had these lame sockets here for the memory, which were up here too, and which I removed, and which showed that there were a few shorts under these sockets, and under the board we have a bit of rework done here, where I cut some traces, or some traces were cut and not fixed. And when all this was done, I introduced a short because some of the solder mask was gone, and so there were some pieces so close together that if you soldered them, they just melted together and created a short, which took out 3 other ICs plus a fuse. When I fixed that, the machine started to work, but at least one of the CIAs was done. Didn't have a SID chip. And then we had the interrupt thing, which cost me another 3 hours, and that was just due to the R100 being a bit too low at 870 ohms, should be 1k ohm. Changed that, and now it works. What a freaking journey. By the way, I have 3 more of these boards here from the same owner, and I will go and I will try to fix them all. So thanks for watching this, and Thanks for sticking. I think this will be a stupidly long video. See you next time.
Thanks again to PCBWay for sponsoring this video. If you need any PCBs, pre-assembled PCBs or 3D printing, please use the link in the description below.
Thank you for watching Retro Studio Black. If you liked this video, please like it, give it a thumbs up. If you are interested in content like this, please subscribe and hit this bell icon. I have no idea if it really makes a difference, but you never know. And yeah, it's an algorithm, so I'm not arguing. However, thank you for watching, and I see you on the other side. Cheerio.